Do you want to find a source of gold that a lot of prospectors ignore? Well, I'm going to tell you about that today. See, a lot of guys don't think about hard rock, and it's to their disadvantage. You know, if placer's great, I like placer, but thinking about hard rock, sometimes you can make some really good finds. I've seen some amazing finds made with metal detectors around old hard rock mines. You don't even have to go in, just on the dumps or nearby, or outcrops of veins near an old mine, that kind of thing. Hey, this last spring, I was out with my metal detector in an old mining area, and I wasn't even near an old mine. I was a few hundred feet on either side of me. There was some old workings, and I found a hot spot on the side of a hill that gave me some nice gold in quartz that I crushed up and extracted the gold from the quartz. And that's what I want to talk to you today. We're going to give you basically a master class, a full coverage of what it takes to extract gold from quartz. And I think you're going to find it's really not only interesting, but potentially very profitable. So the first thing I want to talk about is kind of these old mining areas. And you know, different areas have different kinds of gold in them, different kinds of ores is what I mean. And you know, the first thing to think about is, what do you really have? You know, maybe you've been out to an old hard rock mine and you've seen some bits of quartz on the dump. And I'll tell you, not every bit of quartz on an old dump is going to have lots of gold, but occasionally it really does. So you kind of got to be out there and know what you find, know what you have. And you know, finding out what you have is the first step. Okay, now I do a lot of testing with metal detectors in old hard rock mine dumps, and metal detectors are great for that. Metal detectors will tell you, now there are some sulfides that will sound off on a metal detector, but a lot of times gold is what you find in old quartz hard rock mines. You've got your metal detector out there and it beeps and it shows non-ferrous, and you know you're going to find something good, and you may find a little bit of quartz or a little bit of gold with the quartz. You may find a lot of gold with the quartz, but the easy stuff, that is the easiest stuff to process, is just quartz with maybe a little bit of sulfides, but not much, or maybe some oxidized sulfides in there that have, just by exposure to air and rain over the years, the pyrite has been turned to rust. And so that's the easiest stuff, is quartz. The next is sulfides. So, you know, if you do have a lot of sulfides, because if the ore has a lot of sulfides in it, you're going to have to deal with that in extracting the gold from the quartz. It's going to be a lot more difficult the more sulfides you have. A little bit, no big deal. Smaller, a little bit more, maybe not really a huge deal. Once you get to where it's a lot of sulfides, where you got a lot more volume of sulfides than you got of quartz, yeah, it's more of a pain to deal with it. So, but we're going to talk about ways to deal with it. It can be done, it's just more work. Oxides, it's way better to have ore that's oxidized so you don't have the sulfides in there. And that's a natural process. Ores that are often near the surface, just by exposure to air and rain and that kind of stuff, the air, the oxygen from the air will react with the sulfides and change pyrite to just iron oxides. It'll change things like chalcopyrite, which the iron oxides, or the iron in the chalcopyrite will become iron oxides. The copper will become copper minerals like, you know, malachite or azurite or chrysocolla or something like that. So the oxidized metals are way better to deal with. And of course, you know, how much base metals you have makes a difference too, but the less base metals, the better. So you got to think about what you have and learn about what you have, and then, you know, maybe test it for gold. You know, maybe you want to have an assay done, you pay to have an assay done, or maybe you just want to crush and pan some samples. Now, I did a whole video on crushing and panning and testing samples and doing your own kind of home free gold assay, and I'll put a link to that up here. You want to check that out maybe later, but one way you need to test and see what you have, how much gold is in that quartz rock that you're picking up. And best if it's sounding off on your metal detector, or you can see decent amounts of free gold in it, then okay, you know that you're going to have some pretty good rock. Sometimes though, if you're not seeing free gold, if you're not able to make it sound off at all with your metal detector, you may need to do some more testing. And that's why I say you can do testing with that kind of rock by crushing it and testing it and measuring it yourself. You weigh beforehand what the amount of rock that you're crushing, and you weigh the amount of gold that you get at the end, and you kind of figure, okay, how many grams per ton or ounces per ton in the rock. So one of the things I want to talk about, because I get questions on this, is what's worthwhile? What amount of gold in rock is worth processing? Because you don't want to process, crush up and carefully pan through 100 pounds of rock and you get 1/10 of a gram of gold. You're going to quickly say, yeah, that's just not worth it. So you want worthwhile amounts, and usually the worthwhile amount at a bare minimum is about 1/2 ounce per ton. If you're getting a lot less than that, you're not going to do so great. So a 1/2 ounce per ton would be about 7 or 8 grams per 1,000 pounds, and so 100 pounds would be about 3/4 of a gram. You see, that's kind of bare bones. You crush up 100 pounds of rock and you get 3/4 of a gram. Yeah, I mean, if you got a lot of that rock and you got a good crushing system, it might be worth it. But most guys that are doing it are getting better than that. But if you're a lot less, you're probably going to want to keep looking for better rock.
So if what you have looks like this, you're good to go. You're going to be making a lot of gold. Now, some people might look at this and say, hey, that would be better made into a specimen. And, if the gold were in more solid quartz, this quartz was just highly fractured. You could almost break it up with your hand. Not quite, but it's still so fractured, I don't think you could make a good specimen out of it. So it would be good to crush and you'd get a lot of gold. Now, if the gold you're interested in processing looks more like this, the bulk of this piece of quartz doesn't have any gold, just the area I've circled with the light green. But this is still plenty enough that it would sound off on a metal detector. And if you had, a lot of pounds of this, you'd have a lot of gold. It's not nearly enough gold to consider for a specimen, and the quartz here is nice and tough, but you crush this up and you're going to end up with some good gold, and you certainly would see it with a metal detector. The question comes is if you have pieces like this. Now, I'm sure there's at least a little gold in this. It came from a famous gold mine, but you got to remember that in most mines, the bulk of the vein is low grade to barren. It's only in certain areas where it's rich, and then those are the areas that the miners take out. And so, you could test a piece like this. It wouldn't sound off on your metal detector. You looked at the surface closely, you wouldn't find any visible gold. But you can, crush it down, pan it out, and see what you get. And if you get a lot more than you expect, well, then maybe it's worthwhile. Otherwise, if you crush it down and you don't get much, then you'll know that this is not worthwhile material.
The next step in the process is crushing. You've got rock, chunks of rock. In order to release the gold that's inside the rock, it's got to be crushed. I mean, this is kind of the equivalent of what Mother Nature does through the processes of erosion to release gold to form placers in streams and rivers. But with hard rock, you've got to do the work of crushing. And this is one of the things that stops a lot of prospectors. You can, for very small samples for testing, you can do a hand crush where, literally you've got some sort of a pounding thing. I have what they call a mortar and pestle, and it's just a cup, a metal, cast iron metal cup, and then I've got a pounder on it. And there's various different ones. You can make much larger pounding devices. Basically, the old stamp mill was a pounding device that was mechanized so that the rods went up and pounded down on the rock. And a lot of times those steel things in the stamps weighed like 1,000 pounds each. Obviously, you won't be doing that by yourself with your hand, but it's a process that takes a lot of time, and it's a lot of work. And it's okay for crushing, and old-time miners tested ores in the field doing that for hundreds of years. But to crush rock for a process, you need something a little better. Now for me, my setup for crushing rocks is I have a little jaw crusher, and then I have a small a chain mill, which is basically chains spin around inside it. And so I will show you some of that in a minute. But one of the other things that people ask is, how fine should I crush it? Well, it's like, well, maybe I have 300 mesh gold. Does that mean I should crush all my rock to 300 mesh? It's like, no. People have done testing with that. And, if you pound, basically when you crush something and they say, oh, it's crushed to 50 mesh, it means everything will pass through a 50 mesh screen. But there's a whole lot of stuff down there that's going to be 300, 500 mesh and smaller. It's just the largest size is 50 mesh. And so normally what I suggest, because the gold in ores is often in the more friable, broken, cracked, and easily crushable part of the ore, that going down to about 20 mesh is sufficient. And now you may need to go steps through that. When I crush my ores, I'll go through the jaw crusher and carefully crush it down, and then look for the bigger pieces of gold that are in, because I'm often crushing rock that I found with my metal detector, and so it has some bigger pieces of gold in it. So I will crush it with a jaw crusher, which is a coarse crushing device, and then get it down to where I pick out the bigger pieces of gold that were that you can see and have been freed by the coarse crushing, and then I take the rest of that rock that's real small and feed it through my chain mill, which is basically my fine crusher, and it crushes everything down to like I say, probably around 20 mesh. Although 20 mesh, I still got a lot of stuff in that mix that's 100 mesh, 200 mesh, even 300 mesh and smaller. So you don't want to over grind. That's millmen that have been doing this for centuries, crushing rock and extracting the gold, know that over crushing is a bad thing. It wastes energy, it causes more maintenance, and it loses gold. So it's a loser, loser, loser every way you look at it. So you don't want to over crush. But having a system, there's lots of different things out there, various jaw crushers and other crushers for coarse. But basically, if you're going to do larger amounts, you kind of need some kind of system. And there's various different sizes of systems, but the one that I have is my chainmail. So let me show you a little bit more about my crushing setup and how I use it. Okay, so the first step in going from rocks to gold is you got to crush the rocks to get the gold out. And I have here a relatively small amount of rocks. This is really only a little over a pound of rock. I weighed it up, and yet I expect this will probably have close to a quarter ounce of gold in it. These are all pieces of gold or pieces of rock that I found with the metal detector that sounded off because they had gold in them. Some of them have quite a bit of visible gold in the pieces. I've got some pictures. You can see this is some pretty nice gold. I got quite a bit of nice yellow right in among the quartz here, and this is the kind of stuff we're going to be crushing down and making a nice button out of. And some of them have, not a lot visible, but still make the detector sound off. And that really is one of the big secret of getting gold out of rocks. You got to start out with rocks that have good gold in them to begin with. If your rocks don't have anything but the tiniest trace of gold in them, then tiniest trace is all you can get out, right? Even if you got every little bit of it. And the truth is, usually you miss some. So I'm going to get started with crushing. This is my jaw crusher here. I actually have a motor for this thing, and I'm going to be installing that soon, and I'll show you the motor when I get it installed. But basically, the rock will go in here. There's a set of jaws that one jaw comes like this, kind of rotates on an elliptical type of motion, and as it comes together, it crushes the rock, and as it pulls up out, it allows the rock to go back down, and then it crushes again, and the material works its way through. It goes into this bucket. I'll actually put a little protector in this space here just to keep little chips from flying out, because rock that's got 1/4 ounce of gold and 1 pound of it, that's rock you don't want to be losing chips. So I'm going to have a protector here, and let me show you how this is done. Okay, so here's what we're going to get started with. I have a chunk of quartz here from a mine dump that I detected with a metal detector, and the metal detector says there's non-ferrous gold on the inside. Non-ferrous means it's not steel, it's not iron. And we're going to put this in the jaw. I put this, that's also to hold chips in, and then this is hand operated. I have a motor for this, and I haven't installed it yet. In one of my future videos, I'll show you this jaw crusher operating with the motor. But for now, we're just going to crush by hand. And that's all it takes to crush that rock. I will show you the crushed rock when we get done with this. Now, there's other ways of crushing rock. There's mortar and pestle, where you basically have a heavy steel container and you pound on it. Sometimes called a dolly pot, especially in Australia. Same concept. Basically, you're pounding to crush the rock down. It's a lot of work. Crushing a pound of rock in a dolly pot would be an awful lot of work. It's a lot easier going through this jaw crusher. Now, the jaw crusher is only the first step. We also have a second crusher, a chainmail crusher, which I will show you in a minute. But let me crush this rock down, and then I will show you in a gold pan what the crushed rock looks like. Here's what that rock looks like after the first step of crushing. I crushed it real fine with that jaw crusher.
So here's that crushed rock. The biggest pieces in this are probably around 3/8 of an inch. You know, it's way too coarse for processing right now. I mean, there's still a lot of rock that has gold to be released, but you can see there's a lot of fines in there too. There's a whole lot of material that's probably smaller than 50 mesh, but it's ready for the next step. We've gone through the coarse crushing. Now we can go through a fine crushing step.
So today I'm going to screen my ore, and you might ask, well, why bother with screening this high-grade stuff? Why don't you just dump it all in the chainmail like I'm going to do with the other big bag full of ore rock? Well, there's a reason why I'm doing it, and it's because gold is soft and malleable. And what I have is a chainmail, or a flail mill sometimes they're called. It spins it around at a real high speed in there, and the spinning chain breaks the rock, right? Well, gold is soft and malleable, and it has a tendency to just smear the gold around on the inside of my chainmail. And I want my gold in the finished button. I don't want it smeared around on the inside of my crusher. Doesn't make any sense. So what I'm going to do is I'm going to take this material and I'm going to screen it into 3 fractions. I've got 1/4 inch and 1/12 of an inch, and then whatever passes through that. And I'm going to pick out of each fraction any visible gold material. You know, kind of like visible pieces of gold like that I get out of the screening. And those will go in a separate thing, and I will go ahead and just take those directly to the melt. Hey, I thought I'd get in here with my crusher and show you a few things before we got started. I've opened up the crusher so you can see inside, and what's in there you can see, hopefully you can see this, is some chain that's basically is a big bearing right here, and behind is a motor, and this is a kind of a cylinder shape, although it's a narrow cylinder, it's a shallow cylinder. And there's 2 rows of chains that when the motor's turned on spin around at a real high speed. It's just regular old chain like you could get from Home Depot. I mean, this is the right kind of stuff. And basically it flails around on the inside of that thing and hits the pieces of rock. And of course it goes so fast that the rock spins around and bounces around and then gets smashed by this chain. And then at the bottom here, you can't really see, but at the bottom there's a little screen, and once it gets beat up enough that it's small enough to pass through the screen, it goes out through a hose here, and then I actually have a dust collection system, which you'll see in a few minutes when I actually run it.
So here's another view of my drum crusher, the one that has the chain mill, and you can see the motor and the feed tube with the red on top there, where that's where the material goes in, and then it goes into that drum that I just showed you, and it goes through there and passes through the screen and then out the tube at the bottom of the thing, the black tube that you can see, and then into the dust collection system. Here's the next step. You can see the black tube on the left leads down into the cyclone, and then the material, other than the air, is dropped into the bucket with the blue rim, and the very finest dust goes out through the other tube, and you can see just behind me there's a blue shop vac unit that I use to provide the suction for the dust control. Now I will tell you that if it wasn't for some sort of dust control system, these units do throw quite a bit of dust. So I didn't even try to talk over this. The noise from the mill was so loud, you wouldn't have been able to hear me clearly anyway. So I thought I'd just do a narration over the top of it. And that way, you could see what I'm doing and I could tell you a little bit more about it. The round chain mill has 4 sets of chains that spin around there from a motor at a really high rate, and then that just smashes the pieces because the chains are spinning so fast. It just smashes the ground up ore to bits, and then at the bottom we have material sucked out, and that's been fully crushed because it passes through a screen. I have to feed it in slowly because if you feed it in too fast, it just fills up and the screen gets blinded. And then what happens is the chains slow down because they're beating against the pile of ore that's in there, and then it trips the breaker, and so it's a big mess. So you really don't want to load it in too fast, just a little at a time. That's why you see me being super careful. I've got that red feeder thing that I made because normally it's just a square tube that's vertical on this chain mill. So I welded up a feed, basically a feed slot, so that I could feed the material in more carefully. And the other thing is the chain mill will shoot stuff up the top of the tube there, and so having a top on the tube also helps from material shooting around and everything. And here's all that material finally crushed. This is the full crush stage, and you're ready when you get it down this small to go to your next step. It's all basically the size of fine beach sand or less.
Now that we've got everything crushed down, the next step is to get started with the actual extraction. We've released the gold by crushing it. Now we need to separate it from all the waste minerals that are with it. And gold, like I say, good ore, minimum ore for individual messing with is around a half an ounce. That's a half an ounce in a ton of rock. So when we're talking about extraction, we're talking about taking the gold, that is maybe a few ounces in 2,000 pounds of rock. That's the extraction part. So there's basically 3 different kinds of extraction that are commonly done. One we're going to talk about is leaching. Now, there's an interest in that, and you guys, you should be interested in it. The vast majority of all gold taken out, newly mined gold taken out of the ground every year, comes out by cyanide leaching. And of course, I do not recommend cyanide leaching to you guys. There's a danger. Of course, cyanide is a deadly poison. But I did do a video on cyanide leaching and how it works, and we're going to talk a little bit about that. I'm going to put a link to that up above here, and if you're interested in finding more out about cyanide, then yeah, take a look at that video. You'll probably learn something about it. It's not a how-to video. It's not a video to tell you all the potential problems and dangers. The problem with all leaching, whether it be cyanide or something else, is that it requires chemical knowledge. You need to understand the chemistry of your ore, what things in your ore might be a problem for that method of leaching. There's different ways of doing it. And so the other form of leaching that is actually done commercially, although only a very small percentage, is using thiosulfate. And I have to admit that this summer I tried to do a thiosulfate leaching, but I did it on sulfides, which is not probably a good choice, but I decided to give it a shot anyway, and it just didn't work. But I did talk a little bit about it, and so I'm going to show you a little bit of the discussion I had about using thiosulfate, because I think it has great potential for leaching both silver and gold. And I will do some stuff, and I will make it work, because it's been done in the lab, and it is actually done commercially here in Nevada. There's one circuit of up in the Carlin area where they have ores that are not amenable to leaching by cyanide. They don't work for leaching by cyanide, so they have to leach with something else, and they use thiosulfate. So let's talk a little bit about thiosulfate and get into that. How'd you like to learn to recover the very, very smallest of gold? Really tiny stuff, even stuff that's, hard to see without a microscope. Well, we're going to talk today about gold and silver leaching, and especially about a non-toxic leachant for gold and silver. Now, getting the smallest gold is really difficult, and no matter what somebody who's trying to sell something tells you, when you're talking about 300 mesh gold and smaller, you're just not going to get a large percentage of it. Now, even with 100 mesh and smaller, you're just going to have a hard time getting it. It's a fact that, you may recover some, and if you say, hey Chris, I processed this on my shaker table and I got some 300 mesh gold. Okay, but that doesn't mean you're not missing 50% or 70% or even 90% of that 300 mesh. And for the 100%, or the 100 mesh gold, you may be getting, 70% or 50% or something like that. It just depends on your equipment and the nature of the ore and that kind of stuff. That's why, old timers and miners since 135 years ago have been switching to leaching the very smallest gold using a chemical leachant. But the problem is cyanide. Yeah, the leachant that became on the market in the 1890s and became popular and was used all over the world. I mean, from, the US to Africa to, South America, all over the place. It was cyanide. And cyanide has some things going for it. It does a good job. It's pretty stable. The chemistry's kind of easy as long as you keep it within certain limits. And so, cyanide has become very popular, and something like 75 or 80% of all newly mined gold is treated, at least in part, in a process that involves cyanide. But as individual prospectors, as individuals and stuff, we don't want to be using super highly toxic stuff. And in fact, with sodium cyanide, something around like a half a gram is enough to kill a lot of people. And that's a tiny amount. So we don't want to be involved with cyanide. We want to be involved with something that's not so toxic. And so we're going to look at alternatives. Now there's some alternatives on the market. There's a company that makes a product called Eco Goldex. I tried looking it up and there's just not a lot of information. Some people thought it was a ferrocyanide, so that it has some cyanide, but it's not as toxic. There are Chinese non-cyanide leachants that are available. The problem is, will it work with your ore? Hard to say. Is the chemistry of your ore and the chemistry of others? Well, you don't know what the chemistry is of these products that you get. And like Eco Goldex has different products for different things. And, it's hard to say. And can you make an adjustment in your process to go with those other commercial alternatives? Well, you don't know what it is. So how do you adjust chemically for something you don't know what it is? And that leads to then there's various other non-cyanide alternatives for leaching gold and silver. And probably the best one for the home operator, the least toxic, is a material called thiosulfate. And actually thiosulfate in small amounts is actually used as a medicine. And in small amounts, thiosulfate is actually the antidote for cyanide. So if you accidentally take in some cyanide, it's not enough to kill you right away, you can take a little bit of thiosulfate and it'll neutralize the cyanide and they'll both go away into nothing that's harmful. So thiosulfate, like I say, used in small amounts as a medicine. So it's not very toxic if they recommend it as a medication that you take it. And thiosulfate has been around for a long, long time. The discovery that thiosulfate would dissolve a lot of silver chemicals, but not metallic silver without special treatment, is what led to the development of black and white photography. Because what happens is you have a silver bearing chemical that's light sensitive, you expose it to light, that's what makes the image, and then you develop it using the thiosulfate. And you make a negative and then do the same process in reverse and you get a black and white photograph. And the earliest black and white photographs I think are from the 1830s or 40s. And so thiosulfate to dissolve silver has been known for a long time. And it actually will dissolve both silver and gold. It'll dissolve gold really well too. But to dissolve gold, you need an oxidizing catalyst. That if you just have thiosulfate and tiny particles of gold, it'll take about forever to actually dissolve the gold. That's one of the things about cyanide is that it's able to take oxygen from the air and directly convert the metallic gold particles into gold cyanide. Whereas thiosulfate can't do that. It requires an oxidizing catalyst. And what they normally do is they use in the past, it's always been copper as the oxidizing catalyst. So copper will come in there and it will actually oxidize the copper chemical, not metallic copper. A copper chemical oxidizes the metallic particle of gold to be a dissolved chemical in the water, and then air reacts with the copper and reoxidizes the copper. So you get the copper reduces and oxidizes the gold, and then the oxygen reoxidizes the copper, and the copper just, it goes, it takes oxygen and it does that process where it transfers the oxidizing power of the oxygen to the gold, but it does it, like I say, indirectly through the copper. What the problem with copper is, though, is with thiosulfate, one of the problems with thiosulfate, it's got a tricky chemistry because it's easily decomposed. There's another advantage of the cyanide, is that thiosulfate, it falls apart pretty easy. If you get it too acidic, it'll just fall apart. If you get it too basic, it won't do anything. And so there's a kind of a narrow acid-base range that, can't be too acidic or it'll just decompose, can't be too basic or it won't do anything. So it has to be in that narrow range where it won't decompose and it will do the job. But you have to control the chemistry to do that. And like I say, in the past, this copper has been used, but the problem is copper has a property with thiosulfate that it helps decompose the thiosulfate too. It doesn't just oxidize the gold, it helps to break down and oxidize the thiosulfate. So one of the reasons it's not used commercially in gold mining is because the copper oxidizes the thiosulfate and you end up consuming a whole lot of thiosulfate in order to process your gold. Whereas thiosulfate is actually cheaper than cyanide, but because you use so much more of it than you would with the cyanide, even though it's cheaper per pound, because you use so many more pounds, it's cheaper to use cyanide because you don't consume it. So there's been a lot of experimentation, and people have looked at different things and tried to find, well, copper doesn't work so good, what's an alternative? And they've come up with nickel. And it's, again, not metallic nickel, it's a chemical form of nickel, an oxidized form of nickel, and that the chemical nickel can have some of these properties where it helps take the oxygen from the air and impart it to the gold, bring the gold into solution from a metallic gold particle into something that can be dissolved, and then then the oxygen reoxidizes the nickel, and it acts like a catalyst. The nickel oxidizes and reduces just like the copper does, taking air and transforming the oxidizing power of the air to the gold or the silver. Now, for silver minerals like silver chlorides, which is oxidized silver mineral, you don't even actually need an oxidant. You can, that's how black and white photography works. The thiosulfate will dissolve it directly. But with silver sulfides, like acanthite or argentite, and other more complex silver sulfides, like the ruby silvers and that sort of thing, it does require this catalyst. And one of the cool things about thiosulfate is that it's available through Amazon, but it's not going to work with every ore. One of the things about ores, and I talked about how leaching is great for getting the very smallest stuff, it's not good for getting the very largest stuff. A lot of different types of old-time mill processes, they had a certain part of the process that was for the coarse gold, and then another part of the process that was the leaching process for the fine gold. And so the leaching works very poorly on really coarse stuff. It's just a matter of taking a lot longer to process and to dissolve it, because that's what the leaching process is. It's a process to dissolve the material. And so if you start off with a little tiny, it's like, if I took a spoonful of sugar from the kitchen and put it in hot water and stirred it up, it'd dissolve right away. But if I took a big giant piece of rock candy that was 2 inches in diameter and put it in there, it might take an hour or two to dissolve all that, whereas the other might take a minute or two. And that's the concept of using these chemicals to leach coarser stuff. You want to take the coarser stuff out first and then leach the fine stuff. Okay, so we've talked a little bit about cyanide and thiosulfate. The next concept is leaching, or smelting, I mean. The next concept is smelting. And this is what you're going to end up doing if you have lots of sulfides, lots of base metals, that kind of stuff. You're going to kind of be stuck with smelting. And so what you're doing there is basically melting the sulfide and gold together, and through the melt process, extracting the gold. So basically what happens is you will add a lead or bismuth type of material as a collector and put in nails to reduce the excess sulfide. In almost all sulfides, there's more sulfur than is necessary for the metal that's in it. There's like an excess of sulfur. And so the nails are put in there to help reduce the excess of sulfur, to reduce any lead or other metals like that. And you end up with, at the bottom, you'll end up with a puddle of, or a solid piece when it cools, of lead with or bismuth with your gold and silver in it, and then sulfides or whatever, a matte or other material that's been oxidized on the top. And then the next step is you have to take that lead or bismuth and you have to go through cupellation, which basically oxidizes off the lead or bismuth, and you end up with a silver and gold doré. If you don't have a lot of silver in your ore, then it's just going to be a gold doré. But if there's significant silver, then you end up with a silver and a gold doré, which is a doré is an impure bullion where you've got a mixture of gold and silver. The other one is really the most common thing that most prospectors are going to end up with, and this is gravity or density type, and it makes use of the fact that the gold is so much more dense than the other things like quartz or calcite or other gangue minerals. It's even significantly denser than the sulfides that are in there. And like I say, if you have only a mineral sulfides, you can deal with it and kind of separate the gold from the sulfides. If you have gobs and gobs of sulfides, yeah, you're going to be stuck with the smelting part of things. So the smelting things, if you're interested in that, Jason over at Mount Baker Mining and Metals, Jason does a bunch of smelting and comes up with gold. So, you know, if you're not already familiar with his channel, he's got a lot of good stuff on that end of things. But the gravity density separation, this is what most people will be doing. You'll be either, if you just have small, you know, like this last spring, I had several pounds of quartz that I detected with my metal detector. It's only several pounds. It was, I don't know, 3 or 4, I can't remember, pounds. And so when I crushed it down, I just panned it out, because for such a small sample, panning is fine. You know, it would have been more work to get out a sluice or something else. So just panning down small samples is great. But if you're going to be doing 50 and 100 and 200 and maybe more pounds, then yeah, you don't want to pan through every bit of that. And so there's different methods of gravity separation. I talk about panning tables. Again, Jason uses a table that he makes, but there's cyclones that work really well, and sluices. Let's talk a little bit about gravity separation. Let me show you some slides and talk about that in more detail. Okay, so here I'm at, out here at a friend's claim, and I'm borrowing his gold cube and using it to process the 2 big samples that I had. And the gold cube works great for getting fine-sized gold, and it's a whole lot faster than panning. And I can just take a scoop or so and slowly feed it into there's a screen here, just in case there's any rocks that are too big. Just slowly feed the scoop in, get another scoop, slowly feed that in. And believe me, this is a whole lot faster than panning through, you know, 58 or something like that pounds. I think this sample was 58.4. That's a lot of panning. Let's take a look at a different angle for the gold sluice, the gold cube.
This is just a different look at the same setup. You can see the little screen that I feed into, and then each layer of the gold cube is got a different matting or material in it. I also have this setup here where I've got my river sluice, and I've made a manifold, that's the red thing on the left, that brings water in from a pump and then runs the sluice based on, you know, just recirculating into a tub. And, you know, this is maybe not as good as the gold cube, but it's still pretty good. And, you know, I don't have to borrow my friend's gold cube. I can just set this up in my yard. So I do that sometimes also. Probably the most efficient way to extract gold from a crushed rock and on a gravity type basis, a density type basis, is the shaker table. This is one of Jason at Mount Baker Mining and Metals, one of his tables. I actually went up there and visited him once. Here it shows it running some of my ore. On a shaker table, the light material kind of goes straight down the table into the waste stream, and the heavier materials shake off to one side, in this case, the side closest to the camera. You can see that line of sulfides close to us as it's working its way over to the concentrate section. Here, Jason points to some of the gold that's at the far edge of the line of heavies and sulfides and stuff, but there is some gold in there that's working its way down into the concentrates. Here's just a quick diagram of how a shaker table works with the tailings coming straight down or down slightly. And this is set up with a direction of movement toward the left. And then the middlings or sulfides go further left than the tailings, and then gold, being the densest, moves farthest left of all. A lot of times shaker tables are just too darn big and expensive for the individual operator. There is a small one that's available. This is the RP4. I'm not so sure about how well this works. It's small, and it also shows another thing here where shaker tables need to be very positively anchored down to the floor because they shake, and if they're not well anchored down, they'll shake themselves. But I'm not so sure about the RP4. And even the RP4 itself is pretty darned expensive. Here is another shaker table design. This is at a hard rock mine where they were using this shaker table to concentrate the gold out of the sulfides, or at least produce a really gold-rich sulfide concentrate that they could process to get the gold out of.
And finally, the last step before you might send it off to a refiner to get paid for it is melting your fines into a bar or a button. Now, if you've gone through smelting and you don't have a lot of extra silver in your, or you may have a gold button already, you maybe just want to put several buttons together, or maybe your button's big enough that you can send it directly to a smelter. Usually, when you send off to a smelter, what you want is several ounces at a minimum of gold that you're sending in. They have certain flat fees, and if you send in really small amounts, the flat fee becomes a really big percentage. If you're only sending in a quarter ounce or something like that, the flat fee becomes huge. But if you're sending in several ounces, the flat fees are not that much. So sending in several ounces, if you've done gravity separation and you have fine particles of gold, man, I always melt mine down before sending it off to a refiner. There's a bunch of reasons. I've gone over it in other videos, but for safety and for your knowing how much you're sending in, because usually with placer fines or with fines from gravity separation processes, pans and tables and sluices, your sluice is like a gold cube, something like that, you're going to have some impurities in there, and by melting it yourself, you know how much impurities you've gotten rid of. It's all done on your hand, so you know what any losses are. You just don't have to take the word of somebody who's at a refinery. So melting, now if you have a lot of silver in your concentrates, if you've done smelting or other methods and you end up with a heavy silver alloy, you may want to part the gold and silver. And if you have lots and lots of silver in your, maybe you have 90% silver, 10% gold. Well, that's okay. You can part that. It's already got enough silver in it that you can basically put it in nitric acid. The nitric acid will dissolve the silver part, and you'll be left with basically a black powder. That's your gold. And that can be melted and into a button or bar. So parting is something that's done to separate gold and silver. If you don't have that much silver, then it's really nothing you need to worry about. But I'm going to be doing some videos in the future where I'm going to end up with a high silver to gold ratio, and we're going to go ahead and part the silver and gold and make a purer gold unit and a silver unit. But pouring, basically, I know people use torches and stuff like that. I recommend against that because it's so easy, especially if you have fines and you have your torch, to just go and blow all the fines, right out everywhere, and it's a problem. And so I recommend using a crucible and melting that way, and that way you can have everything in the crucible and have some flux in there. And for fluxes, I use sodium carbonate and borax, usually about 2/3 sodium carbonate, about 1/3 borax, and then maybe 4 or 5 times by weight flux over what you've got for your metal. And then I just melt it and pour it into a bar. Let me show you. It's fun. I always enjoy pouring it. Let me show you an example of that. Okay, so we're ready now. We panned everything out. Well, actually, we crushed the rock. We panned it out. We got our gold, and we're ready to put it in a graphite crucible in my furnace here, and we're going to melt it all down. I'm going to mix the gold that I've got. This is the coarse gold and the fine gold together. We're going to mix it with some flux about equal volume, and this flux is a mixture of sodium carbonate, sodium borate or borax, and a little bit of silica sand. And there's a little tiny bit of silica sand in there too. And anyway, we'll about equal volume of the coarse gold and the fine gold that I've got. We'll mix them together and then melt it out. So it's kind of a funny angle, I know. I'm shooting through a window because the way my work shed is set up, literally, if I were to set up the camera behind me, all you'd see is my back. You wouldn't be able to see any of the furnace or the melting or anything else. Once I get it melted, I'm going to pour everything into this little graphite cone mold, and the gold and silver, mostly gold, will collect at the bottom there. So anyway, I've got it all mixed up and taken care of, and I'll bring you back and show you things when we got the little quick melt kiln on burning and operating, and I'll show you all that, and then of course I'll show you the pour. Okay, I think we're up to temperature, and I'm gonna heat the graphite mold, and then we're gonna make the pour. I may cut through a few things because heating the graphite mold isn't exactly exciting, but I'll get you in for the pour, that's for sure. Okay, now for the pour. It doesn't take very long, and I saw the metal go out there and it went into the bottom. Let's see what we got in just a minute when we let it cool, and then we'll flip it over and see the button. Okay, it's had a few minutes to cool. Let's take our mold and turn it over and see what our button looks like. Oop. Popped right out. Trying to turn it over, I know it's hot. Oh, looks great. Let me get a hammer. Okay, I got my hammer. And there's our button of gold. Sure you can see it. I'll get you a closer up picture in a second, and we'll weigh it out and see what our final tally, what we actually got. Looks pretty impressive to me.
So here's our button close up. You can see it's over 15 grams. I calculated this out. That's like 0.49 troy ounces. So we came right up close to half an ounce. I was just really surprised and happy with the total result. And of course that includes both the bigger bulk sample and the high grade detected in the small jar. So you can see why metal detecting old mine dumps, hunting hard rock gold ore, is really a good thing. You can, here, like I got almost a half an ounce. And so it can be really profitable. Now, I will say that this button appears a lot more silvery than it really is in real life. I think it's more a reflection off that little silver weigh pan. It's maybe slightly lighter than normal yellow gold, but it's just a trick of the photograph. It really is good yellow gold. And, half an ounce is a lot of gold to be adding to your stash.
Now, of course, when you end up with a gold button, that's just going to make you feel great. It's always a lot of fun. Every time I make a button or a bar, I'm always stoked by it. But, the thing that you got to start with, is to actually find the gold. First, you have to find the ore, or find with your metal detector, pieces of quartz with gold in it. You have to find that stuff, and finding gold is a skill. And to impart to you the skills that I have, that I've been prospecting for 40 years, plus I have a degree in mine engineering. To impart those skills and that knowledge to you, I wrote a book. It's called Fistful of Gold, and I'm going to tell you a little bit more about my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold, because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code, and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount. I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description, more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.